everyone, welcome to Open Source Friday. I'm Kedasha and I work at the GitHub as a developer advocate, and I'm super excited to be here today. Open Source Friday, as you know, is the weekly show that we have to celebrate maintainers, contributors, and the project that makes our life so much easier. Today, I'm super excited to have Victor Dibia, PhD, who is here to show us all about how to build generalizations and infographics with generative AI and LLMs with his project LIDA. Now, Victor is a principal research software engineer at Microsoft, and he does a lot of great work with generative AI and LLMs. And LIDA is a project that he built last year before ChatGPT came to the scene. So I'm super happy to have Victor here today to tell us all about his project LIDA. Hi, everyone. Welcome to the show. Thanks so much for joining us. I'm going to add Victor to the stage and we will get right into the tech. Hey, Victor.
Hi, hi everyone. Great to be here. Thanks for the introduction.
Of course. Super happy to have you here, Dr. Dibia. Okay, that's going to be the last time I say that.
Oh man.
But I think
Oh
it's very
man.
impressive that you have a PhD. Like that takes a lot of work and like a lot of dedication to, education and learning.
Yeah. Well, thanks. Thanks for the kind words.
Okay, he's a little shy. Okay, great. So today we're chatting about Project LIDA, so Project LIDA, from my understanding, is an open source project from Microsoft that Victor built last year, and it helps us to generate like visualizations and infographics for our data. Now, I am super excited to talk about Project LIDA because I've been learning some machine learning stuff, and I'm just like, okay, yeah, I have an appreciation for this project.
Oh,
I
nice.
know what's going on.
Nice. Um.
Yeah, but like tell us more about yourself actually. What does it mean to be in the role that you do?
Yeah.
And like how did you start, having an
Yeah.
interest in generative AI and large language models?
Yeah. Um. So my background is just traditional software engineering. So I did like a bachelor's degree, a master's, mostly covering courses in computer science, software engineering, distributed systems. I did a master's degree in information systems, information networking at CMU, Pittsburgh. And it's just covering topics in software engineering, distributed systems, um, a bit of security. And after that, I did a startup for a little while, moved to West Africa to do that. And then taught at a university, really enjoyed that. Then I figured out I also wanted to learn about like the human aspect of like software tools and systems. And so I ended up doing a PhD in information systems. And so the information systems is this field that looks at you know applying theories from user behavior psychology and using that to sort of understand how people make decisions as they use tools and interfaces. And that was the PhD. I did that in Hong Kong actually. A bit of a
Wow.
rigmarole there. So I did that at City University of Hong Kong. And towards the end, I got a chance to intern with a group at IBM Research, a primarily HCI group, just again looking at like interface design, applying theories from user behavior decision making to study that. But then we worked very closely with the applied machine learning group at IBM Research, and that's really where my AI sort of interest sort of started out. And so I first of all started to look at how we could apply these models, build like multimodal interaction. And so we worked on things like room scale interaction. A person walks into a room, there's a camera array, there's a 3D pointing device, there's a microphone array, and essentially we are doing text to speech, speech to text, vision recognition, point and gesture recognition, and sort of building that into multimodal like experiences.
Wow.
And yeah, and then I started out sort of applying things, and then I started to figure out, hey, like it would be nice to sort of build new models to solve new interaction type problems. And in 2018 at IBM Research, one of the things I worked on was a project called Data to Vs, and I'll just share my screen if you want to put that up a little. Um, Essentially, this project was in 2018, and the title is just automatic generation of data visualizations using sequence models. So these were the state of the art models back then, RNNs. And what this project just showed for the first time was that we could represent visualization generation as a sequence to sequence prediction problem, and we could train specialized sequence to sequence models that could take raw data and then generate visualizations from that.
Mm.
Works if you represent the visualization as text. And so we could do this by just sampling, let's say, the first two rows from the data set. And then we represent the visualization as text. And so in this case, we used like a declarative visualization language called Vega Lite. And so essentially, you could represent your visualizations just as JSON, just like as a JSON object. And we took these pairs of sample data and visualizations, and we made a fairly big data set out of that. And essentially, we just took an RNN, a sequence model, the exact type of model you would use to train like a language translation model. So imagine that you will learn to translate between English and French. You have all these all these pairs of English and French, and so we just replace that with data and visualization, and this model learned to translate between that. And then
Oh,
if the
so
data is big enough, yeah,
just so I understand, just so I understand. So it's kind of like seeing visualizations as a language.
yes, exactly.
Oh, wow,
If
that's
we
so
represent
interesting.
it as text, as a just like a language, in this case, it's just a specialized declarative language to represent visualizations, and you represent
Wow.
your data again as text, then you can get these models to actually just at runtime, you give them a sample of a data set, and they'll actually come up with visualizations that are sort of grounded or contextually grounded in that data.
Wow.
And so it was the first time we sort of showed that this was possible. So the next question is like, I don't know, like why would you want to do that? Um,
Hmm.
and in general, I have this little slide that I sort of use to explain the topic. And the key idea is that like visualizations make data accessible. And
Yeah.
so let's say you had like a couple 100,000 rows of data. But typically you want to make decisions from that, right? And so it just turns out that the human mind has evolved such that we can look at a chart and we can make really fast conclusions. We can look at a chart and say like, hey, no, my sales tends to be highest in the summer, and so maybe I need to devote more of my resources on my marketing dollars, all that kind of thing to the summer. So you could just look
Yeah.
at a chart, make a decision like that really, really fast. And so in general, charts sort of reduce the cognitive burden associated with sort of extracting insights from data. Super important for many fields. However, to create good visualization, it takes quite a bit of skill and effort. So first of all, you need to understand the data. You need to come up with good questions. That takes some bit of skill. And when you come up with good questions, you need to represent them as visualizations in some way, right? What encoding do you use? Do you use a bar chart, a pie chart, a radar chart? What's the appropriate representation for that, right? Then maybe the data might not be in its best format. Maybe you need to apply some transformations to the data, right? Maybe you need to like combine two fields to a new field, do some normalization, all of that. And then finally, when you do all of that, you need to figure out, okay, so how do I actually create this visualization? Do I use Excel or Power BI? Do I write code in Matplotlib? And so there's quite a bit of effort there. So the promise is, what if we could build a tool that will automatically understand the data? In this case, let's say summarize it. In the case of LIDA, um, what if we could, based on this summary of the data, we could generate a bunch of potential visualization goals? And this is exactly what data scientists do with EDA, the
Yes.
exploratory data analysis. But imagine that you get this for free with zero effort. And then for each of these exploratory goals or hypotheses, can we generate complex visualizations without just with zero requirements on the user? And how can we do all of this with high reliability? And pretty much that's what LIDA set off to accomplish. Um,
You know, it's so interesting, and I'm so happy that I've been studying, and it just so happens that I started learning about like data cleaning and all that jazz
uh-huh.
before our stream, because knowing that LIDA understands the data and then can generate goals and hypotheses
Yeah.
automatically from the data, that kind of
Mhm.
blows my mind, because it takes so long to it's like to like clean the data, and then like you
Oh,
see, and then you're just like, okay, what questions am I going to ask about this, and like what
yeah.
am I trying to accomplish from all
Yep.
this? It takes so much time, right? So
Yeah.
like instead of putting all that manpower or man energy into that, you can
Uh-huh.
use LIDA to generate those questions and then
Mhm.
visualize the data, and then
Yeah.
from then you can go on to do like
Yep. Yep.
actual things, actual work.
Yeah. Um, yeah. So technically,
Nice.
LIDA does. Yeah. So one small limitation is LIDA doesn't exactly focus on cleaning the data. But if the data exists, it makes an assumption that the data just exists in a potentially decent format, and then all the other stuff like you know come up with goals, summarize it, accomplish high reliability. All of that is after that. And so data cleaning is just another nice research topic, but it's
Mm-hmm.
something I'd like to talk about at a different time. But that's a little out of scope for LIDA.
Gotcha.
And for the
So sorry to interrupt, but like
sure.
essentially the data should be clean before using LIDA.
I mean, technically, if it's not clean, you still get results. It'll do its best effort. LLMs are pretty cool actually in that way. They're kind of robust to small amounts of noise, and so they'll do a best effort. And if we have some time, we can go to some random data set on Kaggle and just see what LiDAR does.
Dios mío. Okay.
Yeah, how about that?
Yeah, yeah.
Yeah. So the whole idea is how do we create a better visualization authoring experience, right? Go from data to natural language plus natural language intent to reliable visualizations. But a few really really vigilant folks on the internet might be like, but isn't that what ChatGPT and Code Interpreter does already? So there are a few differences. So the first thing is this project sort of started internally as a hackathon at Microsoft Research. So I know Kedashi mentioned last year. It was actually 2 years ago, August 2022. Um, and ChatGPT came out in December. But this project sort of showed how you could sort of take that data, generate like summaries, and then sort of put an interface on top of all of that, generate code, execute it, show the result to a user. And it sort of used the earlier OpenAI models, so the DaVinci series. This space moves so fast.
Okay.
Everybody has forgotten the DaVinci series of models, but they really were the state of the art like 2 years ago. So DaVinci Instruct, um, and now it's once ChatGPT came out, it's essentially the GPT 3.5 turbo models. It just made this app work a lot better. So some of the differences here is that like it provides a Python API and a web API. It has a visualization specific user experience sort of baked on top of it. And then the paper and the research around it sort of focuses on metrics for evaluating this kind of setup. And and so at this point, I'd like to probably switch to a demo. What do you think?
Mm-hmm. Yeah,
Yeah.
sounds great.
Yeah. So
Someone
the
was just asking if there were any examples that we can share, actually.
oh yeah, absolutely, yeah. So the starting point for LiDAR would be to go to the repo, um, which is I think it's already in the chat. And
Yes.
the first thing you want to do is to install it, do like a pip install dash u LiDAR. And typically, if you have GitHub code spaces, you could essentially just click on a code space, start out a new code space. So I have one actually running, and so the the installation step would be to, if you were installing from source, you would do pip install dash e dots or pip install LiDAR. I've kind of done that before just to save us some time. And then to spin up the UI, you would see something like LiDAR space UI, and essentially that just spins up a web interface that
Okay.
sort of built on top of LiDAR. And we'll come back to the low-level Python API experience in a moment. But um, let's start out with the UI experience. And so
Okay.
once you clicked on that, you went to the URL that it provided. Just go to demo. The first thing is you can point it at some data, right? And so let's
Ah,
assume that we pointed at the SP500 data sets. A few things happen. So the first thing that happens is that there's a module called the summarizer, which sort of works in a two-stage process as a two-stage process. In the first process, we take everything we know about like data sets and we compute a bunch of statistics. So for example, we use like pandas to infer that like the first column is a date. We compute the mean and the max. We generate a bunch of samples from that, and then we compute
Oh,
like the number
nice.
of unique samples. So we know how to do this with code, and so we do this first.
Nice.
Next, we take that representation and then we give that to an LLM. And the LLM does things like adding a semantic type and a description field. And so here we know it's a string, but we also need to know the semantic type. It's a date. And in other data sets, something might be just a string, but we need to know if it's a country or if it's heads of state and that kind of thing. Then also we add a description for each of these. We use the LLM to use best effort and just based on its parametric knowledge, come up with these sort of annotations to improve the representation of the data set. So why might we want this? It just turns out even for humans, the more data you have about the each of the columns and fields, the more interesting, grounded questions you can ask of that data. So that's the first piece. So the summarizer does that. The next thing is the goal exploration module, which is the EDA sort of module we talked about earlier, comes up with a bunch of questions for the data, right? And so right now the user has done nothing but hear all these potential questions here. And so the first one was the overall trend of the S&P 500 over the time period. And we express this as like a multitask generation problem where we don't just ask the LLM to come up with a visualization title or hypothesis. We ask it to do three things. Like, first of all, the question, the title of the visualization, and then also a rationale for what we might learn from this visualization. So it just
Oh,
turns out
nice.
that if you express a problem like this, then the LLM sort of comes up with more semantically rich and more likely correct or interesting questions. And so here, and then for each of these questions, um, we get the visualization module to generate some code. In this case, we generate Python code. In the background, we execute that code, do some pre-processing, post-processing, convert that to an image, extract like a base64 representation of that, and stream that back to the user interface. So for each of these questions, the LLM essentially it generates visualizations, and so you just need to select the particular question, and then you can see the visualization that was generated.
Oh, so it already did everything.
Yep.
Like as soon as you gives it the data set,
Yes.
it
Yes.
just does it.
Yes.
Yeah, I agree with I think it's Levi, simply amazing and mind-blowing. No, for real. Like this work takes so much time.
Yeah.
And that's amazing.
Yeah. And another interesting thing is that because the visualizations here as are represented as code,
Hmm.
just like you could ask ChatGPT to generate some code and then ask it to modify that code, you could do that here too. So for example, if you say something like convert this to a bar chart, right?
Hmm.
And so the LLM just takes the user request, takes the existing code, and rewrites the code. The execution engine executes that, does some error correction, and then uh, a line chart is converted to a bar chart.
Nice.
In addition to that, you can also do other interesting things, right? So sometimes the visualization that comes back might not be correct, and the user might not be a visualization expert. So
Yeah.
one way you can support them in making sense of the quality of the visualization is to ask the LLM to retroactively sort of explain what's going on in the chart. So in this case,
Mm.
it makes three types of explanations. So it talks about like just the overall appearance of the chart. And so if you're building applications that have like accessibility requirements, let's say you have users who are visually impaired, you could include a feature like this that sort of describes what's in the chart. So it says that the chart is a bar plot with blue bars representing the stock price over time. The x-axis is this and all of that. So sort of explaining what's in the code and in the chart. And then in terms of transformation, it describes the type of transformation that's applied to the data. And so first of all, it says that the date column is formatted as a date type. There's some sort of error correction going on. And then also sort of describes the visualization. So that's one thing. Another thing that you
Nice.
could do also is that you could try to leverage, we all hear about the very large language models and how they have consumed a lot of data and how they're actually general world experts. And so it also turns out that like these LLMs, so in this case we're using I think GPT 3.5 Turbo. Turns out they've read a lot of visualization books, and you could actually ask them to evaluate visualization code across multiple dimensions. So in this case here, like we ask it to generate it to generate like ratings across 6 dimensions. So the first is bugs. Does it have any bugs or logic errors? Um, so it says that like, hey, no, I give this score 4.5 because the function could be improved by adding error handling to make sure that the input data is valid, right? In terms of transformation, it says that like the data is transformed appropriately. But here, type seems a little low for.
Yeah.
So here it says that like the visualization type is appropriate, but a bar plot is good. However, a line plot might be more effective. And essentially, you could then say, okay, here's all these like assessments you've made on this particular chart. How about we auto repair the chart?
Mhm.
And so it does a few things. So it converts it back to a line chart, and then adds a bunch of annotations. So for example, it sort of plots. It figures out that this is a stock price graph, and it goes back in time, and it sort of suggests a couple of important events to keep track of. And so in this case, it just turns out that some of these events actually have an effect on sort of the stock price
Yeah.
trajectory. So it talks about the Lehman Brothers bankruptcy, 9/11
Yeah.
events, that sort of thing. So yeah,
We
and then
have a
yeah,
Yeah, we have a little question from
sure.
Carlo. They said that the dates are not visible at all. Is it overestimating the quality of the chart?
So what do we mean by the dates are not visible? You mean
I
here?
think it was the chart
Oh yeah,
before this
oh, yeah.
one.
On the chart previously, I was the one who sort of asked it like convert this to a bar chart, and it sort of did that. And ideally, I think if you did ask the LLM to generate it, it probably would be a bit more judicious in the use of like axis. And so that was like a forced error I did myself. And then I asked the
Mhm.
LLM to sort of self critique that chart and then self repair it, and then it sort of fixed all of that error. And so
Mhm.
yes, a good pipeline to have in general would be to first ask the LLM to generate a chart, and then um, retroactively ask it to also sort of self-evaluate the quality of that chart, and then
Mm.
apply any kind of repairs, and so that way you get good quality charts all along the way.
Nice.
Yeah, and
So
so I'll
essentially, oh,
sure
keep going.
sure go ahead.
I was just gonna say, so essentially, LIDA is taking all the packages that we would use, like Matplotlib, Seaborn, and I think one's called Scikit-learn, and it's building the
Yeah.
charts for us based on the data that's inputted.
Yes. So it's configurable. So you could tell it, hey, no, use Seaborn. So
Okay,
you could switch to Altair, which is an interactive web-based, like a Python library on top of Vigilite. You
yeah,
could use Matplotlib, you could use ggplot. So in theory, as long as it's a library that represents visualization as code in any programming language, and we can execute that code, you typically should be able to use that with LIDA. And then
yeah,
you can also select the type of model you want to use. So on the back end, LiDAR supports multiple model providers, so OpenAI, Palm, Cohere, Hugging Face, Anthropic, that kind of thing. Um, and essentially, the LLM is just like a generation engine, so we can swap that out with multiple LLMs and sort of build visualizations. Yeah.
gotcha. And do we need to add our own API key to access
Yes.
those? Okay.
Yes. So technically, you would run this in your own environment,
Mm-hmm.
and essentially, the first step would be to set up an LLM that gets attached to all your requests.
Gotcha.
Yeah,
Gotcha.
yeah,
Okay, let's answer a few questions that we have, and then I would love to know how can we feed it our own data. I know that these are example data in the demo,
yeah.
but let's answer a few
Um,
questions before we show
sure.
that. So Carlos says, is it possible to control the quality of produced charts so we can automatically generate good charts, like setting the predefined
Yeah,
minimum quality levels?
yeah. So, um, so controlling the LLM's behavior, as an ML engineer, you have multiple levers to sort of tweak or control the quality of whatever comes out of the LLM. So the LLM is the primary driver here, and the lowest hanging fruit is prompting. So
Mm,
essentially, um, and LIDA already does this for you, because if we look through some of the code, and so I'll just go through that. LIDA components, V's, I think V's generator. So there's like a base system prompt that sort of tries to guide the LLM as to how it should generate visualization. And if you did read this out carefully, you'd see that like there's all these
gotcha.
instructions around like writing perfect code for visualization. It sort of says, oh, you must follow visualization best practices. So that's like, as an ML engineer, this is your first lever to sort of control and ensure that like the quality of the chart is sort of good. Um, the second thing you can do is I sort of showed this like self-evaluation capability, um, where you could actually take a visualization and get the LLM. So there's a self-evaluation module. You get it to sort of evaluate a visualization across multiple dimensions. So you could run this just as part of your pipeline before you show anything to your user. So first of all, you have good prompts. You get the first version of the visualization. You pass it through like a self-evaluation module like this. You get like a set of critiques and suggestions. And in this case, everything is sort of high. You probably, if you could then check, you know, if the visualization meets quality on these dimensions. And then finally, you could, if there were low versions, you could then tell the LM, okay, use the self repair module and fix all of these dimensions. And that's like one general way to improve quality.
Gotcha. Makes sense. Another question we have is from Levi. He says, does LIDA implement any hypotheses testing for the data supplied? If the data supplied is not normally distributed, what
Right.
measures does the LLM take into
Yeah.
consideration to fix it?
Yeah. Um, so one of the current limitations of LIDA is that it makes some assumptions about the data. So it assumes that the data is in a fairly decent, like, does not need additional like let's say data cleaning or that kind of thing. It assumes the data is sort of cleaned and in a good state and it's ready for visualization. So that's one thing to note. The other thing around hypothesis testing is, I think we will need to, if you really wanted to focus on hypothesis testing, we would need like an additional, like, let's say, some hypothesis module that sort of looks at data, let's say, explores statistics of each column data and can represent that in some way to the visualization generator at test time. In the current implementation, though, one of the reasons why we include things like minimum, maximum value of particular columns, withdraw samples, is to sort of take a best effort approach to give the LLM as much information about like sort of the overall general behavior or the general properties of each column of data. And a lot of like examples we've run so far show that like the LLM can utilize this sort of signals while it writes code to generate visualizations. But yes, the first step is that adding rich signals like this to the data summary, which is attached to all the requests made to the LLM, is one way to ensure that the LLM makes fairly good decisions. Another way would be to add an additional just like hypothesis exploration module that comes up with additional like directions that the model should focus on and sort of append that, let's say, to the summary.
Yeah, cool. And in regards to the, I guess, the model testing or like analyzing its own work, how do
Yeah,
we swallow the emotional damage of the AI telling us that the code is not good?
that's funny.
That
Um,
was just a funny question that I saw.
yeah, yeah.
Um,
So was there a question about the LLM evaluating itself?
No, but how does it do that?
Yeah,
How does it
yeah,
evaluate itself?
yeah. That's an important question. So there's something a little fishy about like an LLM evaluating its own code.
Yeah.
Definitely is fishy. Definitely is it's an important question to sort of triage. So visualization quality is a fairly subjective thing, and so things like aesthetics, encoding. So some of this those aspects are subjective. So ideally, we would need like some human expert to do that. But in practice, right, you want an approach that's offline,
Mhm.
and the general current approach is to use a very capable model, your most capable model as the evaluator. And so mostly because let's say your most capable model is probably very expensive and you probably can't use it for all of the steps in the pipeline. So you probably can use it for hypothesis summarization, hypothesis generation, all of that stuff. And
Mhm.
you would reserve that model as your evaluator, and it can sort of evaluate the quality of the visualization generated by smaller models. And so right now, the main thing you would do is you just reserve. So in this case, ideally, you would use GPT-4 or the most capable version of GPT-4 as your evaluator, and you would use GPT 3.5 or let's say some models from Hugging Face um, as the core model that drives all the other steps. Um, and outside of that, you would use a human evaluator. There's no easy other approach to sort of evaluate quality of visualizations. One
Gotcha.
additional thing that's sort of new. So when I worked in this, there were no multimodal models, and so what that
Mhm.
means is that now with multimodal models, as opposed to just giving the LLM the representation of the visualization as code to critique, you could also take both the image of the visualization and the code and give that to a multimodal model. And now you can get like evaluations that look at the actual representation of the visualization in pixel space. So what does it look like? And there are a class of problems that you can only detect, quality issues you can only detect in pixel space, things like overplotting or axes that overlap or that sort of thing. Maybe text that's just like very difficult to read, that sort of thing. And so exploring a multimodal like self-evaluation approach will probably improve the performance of a system like this.
Gotcha. Nice. And so, like, how would we ask LIDA to, I guess, evaluate and chart our own data?
Come
What
again?
is that process? How do we feed it our own data?
Oh,
What does
yeah.
that process look like?
So from the UI perspective, you could literally just drag a file in here, a JSON or a CSV file. And fun fact, should we try to get something from Kaggle real fast and
Yeah, let's do
try to
it.
do that? See what happens. Say Kaggle data set. Um, let's see. Um, which one should we select?
Emotions? I don't know.
Yeah, let's take a look. Oops. See how many columns. It's got just 3 columns. Probably not that interesting.
Not
Let's
that
try
one.
another one.
Yeah.
Um,
Top YouTubers worldwide? Okay.
let's see that. Let's see. See how many columns does this have? Okay, 9 columns. Let's try it. Let's try this.
Yeah, let's try that one.
I'm just gonna. Okay, so we have a YouTubers, the CSV, and if all goes well, I will just drag that in here.
Oh, nice.
Um,
Where did it go?
okay, so the first thing it's done is that like it's come up with like, you know, let's start with this. So it's come up with like a representation of the data, And so let's see what kind of questions it came up with. It says, what's the distribution of subscribers among the top 1,000 YouTubers? And let's switch a model to a capable model. Let's see. Let's try
So,
it.
like Victor, of course, you're going to review the work that the AI did, right? But like, this is amazing. Like,
Yeah.
I'm
So,
saying, of course, you're going to review the work that the AI did, but like, this is really amazing. Like, it did a summary. This is like, okay,
yeah.
here's what the data is about. And then it says, okay, here are some questions. Then it
Yeah.
says, okay, here are some charts.
Yeah.
Like,
It
what?
says, what is the distribution of subscribers across different categories? Says what countries have the highest average reviews. Is what is the correlation between average likes and comments? What's the distribution of content types? Yeah, let's see.
Mm.
It looks like we are having some errors. Okay, let's try another one. So one thing that could happen is in a small fraction of cases, the LLM might come up with questions that maybe they're not sufficiently grounded in the data, and so maybe there might be like columns that like um, okay, let's see what this says. Which countries have the highest average reviews? Okay,
Ah,
so United States, Japan, Spain,
right.
Turkey, Iran. Okay, this looks sensible to me. Let's try another
Yeah.
one. What is the correlation between average likes and average comments? Do
Oh,
you
that's a good
see?
question.
Yeah, look at
Oh,
that.
it's got a plot.
Yeah, let's do something fun. Let's say, can you add a line of best fits to the plot? To the plot. I have no idea what it will do, but let's see. So while this is running, were there any other questions?
Yes, yes. Someone asked if LIDA is built on top of AutoGen Studio. I'm not sure what
Um,
AutoGen Studio is.
yeah. So it's a different project that I've been working on, and so I think maybe what they're referencing is that the color scheme looks similar. So
Ah,
AutoGen Studio just came out like 2 months ago. Lida is about
okay.
2 years old, so no, it was
Mhm.
not built in AutoGen Studio. Um,
Awesome. And someone was asking if you can remind them how to access the demo website.
yeah.
I think
So
you opened up the project in a code space.
yeah. So essentially, I did spin up the project in the code space. And so the overall approach will be to go to the LiDAR repo. And so I don't have a hosted version of this. You would need to like install it locally on your machine. And the way you will do that would be that you would run pip install LiDAR. If you had it previously, you might need to update some libraries that it depends on. um, you would make your OpenAI API key. So by default, it uses an OpenAI API key. You need to set that up in your environment. And then you run this command here that says LiDAR UI dash dash port 8080. And so this will just spin up the interface on port 8080 on your local machine. Um, but however, you actually don't need. You could also run it as a notebook. So there's a button here that says open in collab. And so essentially you
Oh,
could run this in a notebook completely. So this just like shows
nice.
the Python API. It shows how to set up multiple LLM providers and all of the things we just showed in the UI. You could do that in the notebook, right? So for example, to
Mhm.
create a bunch of goals. So first to summarize the data, you just say LIDA.summarize and you point it at your data. Pretty straightforward. To generate a bunch of goals, say LIDA.goals. Then you can sort of look at all the goals that it comes up with. You could generate goals based on a persona. And then for each of these goals, you could ask it to generate the visualization. Um, you could generate, you could just ask your own type of question, get a visualization out of that. And then all the things around like asking questions, modifying an existing visualization based on text chat. Um, so you could do that here. In this case, we say like make the chart height and width equal, change the color of the chart to red, translate the chart to Spanish. You get that out. Then explanations,
Nice.
recommendations, and then if you do have a GPU, you could actually do the whole like infographics thing where we could take an existing visualization and use a diffusion model, maybe some like stable diffusion, to sort of go from just a regular visualization to, let's say, stylized version of a visualization. So I think I have like some examples here. So this part is still experimental. So
Mhm.
um, it's not the core focus of LIDA, but it'll be great to see contributions, people sort of figuring out how to make this a bit more stable,
Yeah.
explore more examples here. Yeah.
Yeah, awesome. So we have more questions. Hugo says, can they stream the intermediate steps as LLM is doing its processing?
So yes, so that might require some updates to the core library. So right now, okay, so for most of the steps, right, you really can't consume. Uh, Essentially, let's assume that like we're talking about the visualization module, right? We're generating code to create a visualization. The entire code needs to be generated before you can actually execute it. We can execute partial code and all of that. So technically, you still need to like generate the entire thing. But let's assume that you wanted a user experience where you were sort of showing the user what exactly the LLM was doing at the token streaming level. Um, that might require some modifications to the underlying library. But the good news is it's open source. You technically can do anything with it.
That's
Yeah.
true.
Yeah.
Okay, great. Can you use a local
Yes.
LLM?
Yes. So if you recall the in the notebook I just shared,
Mhm.
LIDA uses a library I wrote, something called LLMX, and technically it lets you use multiple LLM providers. So you can use OpenAI, Cohere, Palm, or even a Hugging Face model. And in theory, a lot of local LLMs can be set up using tools like, let's say, LM Studio or Llama, VLLM. And what that gives you is that it lets you spin up an API endpoint, an OpenAI compatible like LLM endpoint on your local machine. And so that's what I would
Nice.
actually recommend. And so you take any of these nice Hugging Face models like Zephyr, 7 billion parameter models, 13 billion parameter models, and you use like a server like Olama or LM Studio, and you spin up an OpenAI compliant endpoint, and you will just use that exactly how you would use like an OpenAI API. So
Nice. That's pretty cool. That's pretty cool. Okay, more questions, more questions. Uh, does LIDA support real-time data stream?
um, real time data stream.
Yeah.
So technically, if you think about the visualization problem, you do need like a big chunk of data, right? In order to
Yeah.
visualize it, you need like a sufficient sample in order to visualize it. So, as the ML engineer, you have a lot of latitude on how you might build something like this. If you do have like a data source that's streaming, and so it comes in real time, you can figure out some sort of chunking strategy where you essentially let's say within some sort of window, you generate a chunk, you visualize that chunk, and you update data source as the chunks or as more data becomes available, and you generate visualizations. I mean, in theory, you probably want to fix the visualization and just rerun the exact same code um, once the data becomes available, or once
Yeah.
more data becomes available. Yeah.
Yeah. That makes sense. That makes sense to me. Another question is, what do you personally use LIDA for the most?
Oh yeah. So I'm a visualization expert. Spent like many years studying data visualizations. And so I I might use LIDA. Let's say I have like some data and I have like a talk I want to give, and I just maybe I had like a version of this interface running running locally. I might just drag in my data and essentially ask for a bunch of visualizations, maybe put that in a slide deck, that kind of thing. Um, so that's kind of like my own workflow. Um, and I'm happy to like chat with the interface, request changes here and there until I get like the perfect visualization. But
Yeah.
a tool like this, my intuition is that a tool like this is most valuable to users who really have no visualization experience. Like um
Yes.
really without like essentially they're not exactly sure about like, hey, what questions do we even ask?
Yes.
Um and for each of these questions, like why is one better than the other? Like, is this the best visualization for this data? So I think for users like that, a tool like LIDA has the most like delta in terms of like benefit.
I agree. Like I have a workshop coming up in 2 weeks, and the first part of the workshop is to like clean and visualize data and like build a model. And I think I'm going to be using LIDA because the audience,
Yeah,
they're not machine learning or data
yeah,
scientists
yeah,
folks, and I think this just makes it a lot more accessible.
yeah,
So I'm already thinking about like a
yeah,
great use case would be like workshops and like teaching,
yeah.
because it's a lot more accessible and you can digest it a little bit better.
Yeah. So at this point, I've talked about all the things you can do with a tool like this, and
Yeah,
it's important to note that it's not magic. It still has a
of
lot of
course.
limitations, right? And I also find that it's important to talk about like when it doesn't work and um what are the current limitations. And so there are still cases where, let's say you gave very, very complex instructions, the current like code execution path um might LIDA might write code that has like logic errors in there. You try to
Yeah,
run it and then it fails, you see errors. um Now there's a way to solve problems like that, right? So you can just add like an agent, some sort of agent based behavior where you take the compile errors and you give that back to the model. Then you ask it, hey, do some self repair based on that. So that's one approach. I
mm,
mean, there are latency constraints there, so you might see things like that. The second thing is, not all models are equal. So in my demo here, I'm using the GPT series models. If you use smaller models, 7 billion parameter models, 13 billion parameter models, the difference in behavior can be extremely, like, pretty
different.
extreme. Yeah. And that's an open area of research for, how can we build better
Yeah,
smaller models that do better at tasks like this, because it just makes the entire space even more accessible. So these are potential areas of contribution. um, the third thing is it like the quality of the visualization. It relates to the grammar that you choose. And so most of the time I use Seaborn because it's one of the most popular like visualization packages out there. And yes, there's just so much examples of these things on GitHub, and these models have seen most of GitHub, so they're quite proficient at writing like code using these grammars. And so if we start to look at things like, let's say your company has like a proprietary visualization tool, this LiDAR might not work very well there. Um,
gotcha.
yeah, and there's some metrics that the paper has. There's a paper for LiDAR about how you might measure and benchmark systems like this. So these are things that as an ML engineer, you should care about. Yeah.
Yeah. That makes complete sense. That makes complete sense. Definitely not magic. Definitely not, automatically, like you shouldn't automatically trust the output, but
Yes.
it's definitely a good first start,
Yeah.
especially when it comes to understanding large data sets. So I have two more questions that I can ask, and then we're going to wrap up. So the first question is, what input data source is supported? So we know CSV is supported, we know JSON is
Mhm.
supported.
Yeah.
Uh, Carlos said, what about raster data or other binary data containers?
So so essentially the short answer is whatever pandas can process is supported. Whatever the pandas.
That's a
So
great
we
answer.
we we we, we standardize on pandas. Now, for many business use cases, this is insufficient. You probably have data at scale much larger than what
Yeah,
pandas support. So essentially, the solution would be to rewrite your own just data ingest engine. And so there's another opportunity for contribution. To rewrite like how we fundamentally process data in LiDAR. And so it's an open source project. Lots of potential here to make that type of contribution. um, and also just supporting data connectors, right? So most production deployments don't have data just lying around in CSV or JSON files. The data is sort of
Yeah.
data exists in a lakehouse, BigQuery, Postgres SQL, MongoDB, that sort of thing. And so figuring out a good general data connector that lets you just import your data to a tool like this is just something not yet supported in LIDA, but it's a good idea. And so I've heard a lot of good things about Project EBIS is another upcoming open source project. So yeah,
Project what?
EBIS or IBIS. I just know IBIS project data format. I think it's this one.
Is it the one
Yeah.
with the little geese? Oh
So
yeah.
it's this one. It's meant to be like a portable data frame library, and the idea is
Ooh.
that like your data might be in DocDB, ClickHouse, BigQuery, Pandas. You can do the exact same Pandas operations on the data sets without worrying about where the data comes from.
Ah, nice.
Yeah.
Nice. It's interesting because someone else was asking if they could just take data from like SAP or ServiceNow and
Oh
pop it
yeah,
into LIDA
yeah.
or
So
maybe
this
like
might be the
Firebase.
way to sort of think through like a problem like that.
Yeah. Cool. That's really great. Final question for the evening is any chance to submit two snapshots of the data and ask LIDA to compare them?
So,
Huh?
so,
Do
so
you mean snapshots of the charts or snapshots of the data itself?
yeah, yes. It's a LiDAR will not like it's not redesigned to compare like data.
Yeah.
Yeah, it's mostly meant to like the input it takes is a data set and then it provides an output visualization. If what you meant was to compare, let's say, the quality of two different visualizations,
Yeah.
what you could do is that you could get LiDAR to generate like two visualizations and then run the evaluation module on both of them and sort of look at the scores. And
Oh, interesting.
yeah, so you could yeah, so essentially you could explore the examples in the notebook and just do exactly that. Get two visualizations. And then for each of these visualizations, you run the LiDAR that evaluate module and just sort of compare the scores for both of these visualizations.
Nice. That's pretty cool.
Yeah.
I like that. I like what this person said. They said that it's so great to treat visualization as a language. It's a really great multimodal thinking that's going on right here. And
Yeah.
I think that's so true. I'm so impressed by like, oh yeah, just treat this as a language and just translate it
Yeah.
into a chart.
Yeah.
That's pretty cool. This has been really great, Victor. Really great, really informative session. I know everyone watching has enjoyed seeing Project LIDA. I know I have, and I'm going to be digging into it, especially since this is what I'm learning. So I'm just like, what? This is so cool. Thanks so much for taking the time. The final comment I saw is imagine how middle managers are going to believe now that data mining now only takes 5 seconds because AI. Um, I thought that was funny. But
Yeah.
thanks everyone for joining us. Thank you so much for Victor. Any last words you want to share with the audience on how to contribute and
Yeah.
support LIDA, all that jazz?
Yeah. So two things. LiDAR is open source. So I think the link has been shared there. Give it a
Yes.
star. There are a lot of people who have started contributing. So right now we have 12 contributors. You could be contributor number 13. And if you went to the issues, think you could just look through all of them. I probably should do a better job of labeling them. But there are a few of them that, if there's a complaint, something doesn't work well, typically this is just an excellent place to start helping. It might be, just telling others, hey, here's how you fix that problem. It might not even be code contributions. Um, you could look through the documentation, find issues there, propose changes, open PRs. This is all welcome. I really look forward to seeing more of you um, share your ideas. There are things I talked about here today, things like enabling multimodal evaluation, enabling multiple data connectors, let's say using Project EBs. These are all potential areas of contribution. And so that's it. And I also write a newsletter,
Nice.
mostly just talking about like how I think about like AI, machine learning, and design problems. And there are a couple of posts around. I think there's one about LIDA. Let's see. Let me see if I can put that in the chat. Yeah, there's one about LIDA. This could be another place to learn more about the project and that sort of thing. So yeah.
Yeah, I'm popping the newsletter link in the chat right now. Google superpowers. But that's awesome. Thanks so much, Victor, for joining us today. I hope to stay in touch with you, especially as I'm learning this stuff. And you're kind of an expert in this area, or you are an expert in this area, not kind of. But yeah, thanks so much, everyone, for joining us. This has been a really good session, really informative session. I've learned so much, and we'll see you next week.
Thank you. Thank you for having me. Bye.